So the quadratics we've seen so far were written in that form ax squared plus bx plus c. We don't always see quadratics written in that form, though. We might see them written in a different form. And this new form is called the standard form. And this is actually a very useful form because if you think about transformations, this minus h tells us it moved to the right h, and this plus k tells us it moved up k. So that tells us where the vertex is. The vertex is going to be at the point h comma k. That's why we sometimes call this vertex form. Notice that this coefficient in the front, a, is still that same a that we had there. So if that a in the front is positive, it's going to open up. If that a in the front is negative, it's going to open down. But this form is a very easy way to get the vertex out of the equation. So let's use that. Determine whether this function, 3 times x minus 2 squared minus 4, has a minimum or maximum, and find the value of that. Then find the axis of symmetry. So we know that because this a is positive, this parabola is going to open up, so it's going to have a minimum. We know that it moves right 2 and down 4. That comes from the minus 2 here and the minus 2 there. So the vertex is going to be at the point 2 comma negative 4. That means my axis of symmetry is at x equals 2, and the value of my minimum is negative 4, which occurs at x equals 2. Okay, so here's one where we have the graph and we're trying to write the equation. Well, notice that we see the vertex here at the point 2, negative 3. So remember, a quadratic at the origin would be y equals x squared. This one that we have moved right 2 and down 3. We want that a in front to still be 1 because it's opening up. So to go right 2, we're going to subtract 2. To go down 3, we're going to subtract 3. So the equation of this shifted parabola there is y equals x minus 2 all squared minus 3. You could check that by putting that equation into Desmos and seeing if the graph matches.